Welcome to lesson number 8, Combining Transformations, part 2. We're going to start by looking at class example number 1, where I have the graph of y is equal to f of x, and this is equal to y equals x squared. But let's consider the function defined by the equation y is equal to 2 f of 1/2 x plus 5 minus 8. If the equation is written in the form y is equal to a f of b x minus h plus k, we want to say the values of a, b, h, and k. So first of all, value a is substituted with 2. Value b is substituted with 1/2. Value h has been substituted with -5. Because we got a double negative going on here, which makes it positive. And we have value k, which is substituted with -8. Now we want to write the transformations associated with these parameters a, b, h, and k. So first of all, value a, this is going to result in a vertical stretch, and this is going to be along the x-axis. So vertical stretch by a factor of 2. Then we have value b here. This is going to be a horizontal stretch. Horizontal stretch by a factor of 2. Then we have value h, and this is going to be a horizontal translation, 5 units left. And then we have value k, and this is going to be a vertical translation, 8 units down. Now we want to put these transformations in order, which can be used to sketch the graph of the function, and then we want to sketch the graph of the function. And when we're doing the order of our transformations, remember that we can follow the stretches, followed by reflections, and then our translations. And since we started with stretches, we can use this order shown above. And so if I carry out each one of these transformations, then I'd first begin by doing my vertical stretch. And so I take my y value. So at 1, this would go up to 2. Sorry, there's 2 here. At 4, this would go up to 8. And so my first transformation would look something like this. Then I have a horizontal stretch by a factor of 2. So all these would come out to 2 here. And then the 2 would come out to 4. And my next transformation would look something like this. And then I'd have my horizontal translation, my vertical translation. So I'd move 5 units to the left. And this is up here. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And then these would go 8 units down. So 2. And so my line is going to look something like this, and then extending upwards. Now we want to write the equation for my transform function. The original equation was y is equal to x squared. And now we want to start with my transformations. So first of all, I'm going to use my replacement notation. So y went to a factor of 2, so that would be 1/2 y. X was replaced with 1/2 x. X was also replaced with x plus 5. And then y was replaced with y plus 8. And so first of all, if we start with our stretches, we would have 1/2 y is equal to x squared. And if I put this in terms of y is equal to 2x squared. And then I could replace with my horizontal stretch where y is equal to 2 times 1/2 x squared. And I could then replace this with my and actually I'll simplify this first. So if I simplify at this point, y would equal to 1/2 x squared. And then I could substitute my horizontal translation. Y is equal to 1/2 x plus 5 squared. And then finally I can place in y plus 8, and y plus 8 is equal to 1/2 x plus 5 squared, or y is equal to 1/2 x plus 5 squared minus 8. We're going to look at class example number 3 now. We want to consider the function y is equal to f of x. In each case, we want to determine the replacements for x and y, which would result in the following combinations of transformations, and the equation of the transform function in the form y is equal to af b of x minus h plus k. And so we have a horizontal stretch by a factor of 1/4 about the y-axis and a vertical translation of 5 units down. So first of all, I have to replace with my stretch x to 4x. And then a vertical translation of 5 units down would be y to y plus 5. And if we put these into my function notation, we would have f of 4x, and then we have y plus 5 is equal to f of 4x. And writing this in terms of y, we would have y is equal to f of 4x, subtract 5 from both sides, and I get this. Next, we have vertical stretch by a factor of 3/5 about the x-axis. So that's going to translate to y to 5/3 y. And we also have a reflection in the x-axis, so x to negative, in the y-axis, next x to negative x, and a horizontal translation to units left, so x to x plus 2. Now, if I plug all of this in, I'm going to have 5/3 y is equal to f of negative x plus 2. And if I substitute this over here, then I'm going to end up with y is equal to 3/5 f of negative x plus 2. Next, I have a function g of x, which is equal to x cubed, and it's transformed into a new function p of x. And we stretch this vertically about the x-axis by a factor of 0.25. And so by a factor of 0.25, y would be replaced with 4y. This means stretched by a quarter. It's reflected in the y-axis again, so x would go to negative x. And we have a translation 3 units to the right, so x gets translated to x minus 3. And so if we plug this in, we're going to end up with y is equal to a quarter x cubed. My original function is x cubed. And if I input everything else here, y is equal to 1/4 negative x cubed, which we could simplify to be y is equal to negative 1/4 x cubed. And finally, I'm gonna substitute my x minus 3 in, so y is equal to negative 1/4 x minus 3 cubed. And this is my final answer. Or it says function p of x, so I guess p of x is equal to negative 1/4 x minus 3 cubed. Next, I have class example number 6, where I have the function f of x is equal to the square root of x, and it's been transformed into the function g of x is equal to negative 2, square root of 3x minus 12 plus 5. We want to complete the following statement. The function f of x has been transformed to the function g of x by stretching horizontally about the y-axis by a factor of. So if we look at this function, we can simplify this by looking at what the horizontal stretch was on my x. So if I factor the inside, this would leave me a 3x minus 4 plus 5. And so this gives us our horizontal stretch, or otherwise known as our b value in some cases. And so we have a horizontal stretch by a factor of 1/3, and we also stretch vertically about the x-axis by a factor of 2. Also reflecting in the x-axis because we have that negative in front of our vertical stretch. We then translate 5 units up and 4 units horizontally to the right.